Okay, welcome students to section 8.8. Okay. 8.8 is differential equation with non-constant coefficients. Okay, definition. Okay, a differential equation of the x to the nth y to the nth derivative plus a1 x to the n minus 1 y to the n minus 1th derivative plus plus a n minus 1 to x to the y prime first derivative plus a n y equals 0, where a1, a2, to an are all constants. Is called a Cauchy-Euler equation. And to solve a Cauchy-Euler equation, we use the fact that the solutions will be of the form y equals x to the r. For a second order Cauchy-Euler differential equation, if the roots of the initial equation r squared plus a1 minus 1 r plus a2 equals 0. If the roots of what we call the initial equation are of the form distinct real roots, then y1 equals x to the r 1 and y2 equals x to the r2. Okay, whatever those roots are. Okay, if they have repeated roots, or a repeated real root, I guess that should not be plural. If it's a repeated real root, then y1 equals x to the r, and y2 equals x to the r times the natural log of x. Number 3, if they have complex conjugate roots, a plus or minus bi, then y1 equals x to the a times the cosine of b natural log x, and y2 equals x to the a times the sine of b natural log x. Okay, let's look at an example. Number 1, solve x squared y double prime minus x y prime minus 8 y equals 0. Okay. Okay. So y, we said that we have y equal x to the r power. Okay. If we look at our indicial equation, okay, what's a1? Okay, a1 is the coefficient, okay, of the second term. Okay, it's the numerical coefficient. That's -1. What's a2 here? A2 is the coefficient of the third term. Okay, the y term, and that's -8. Hmm. And they're saying that r squared plus a1 minus 1 r plus a2 equals 0. I want to find the roots of that indicial equation. So r squared plus -1 minus 1 r plus -8 equals 0. So r equals, or sorry, so r squared minus 2r minus 8 equals 0. And that's going to factor into r minus 4, and r plus 2 equals 0. So r is equal to -2. That would be r1, and r2 is equal to 4. Okay. So since there are two distinct real roots, okay, then my solution for y1 is equal to x to the -2 power, and y2 is equal to x to the 4th power. And so any linear combination of this is going to give me my general solution to the differential equation. So c1 x to the -2 plus c2 x to the 4th. Number two. Okay, solve the initial value problem. X squared double prime minus 3xy plus 13 equals 0. Given that y of 1 is equal to 2 and y prime at 1 is equal to negative 5. Okay, so let's look at what A1 is and what A2 is. Okay, so A1 is negative 3 and A2 is 13. Okay, so I'm going to go r squared plus a minus 1r plus A2 equals 0. Okay, and so this is r squared plus negative 4r. I'll just do minus 4r plus 13 equals 0. Okay, and this guy does not factor. And so we're going to say r equals plus or minus, negative 4, negative of a negative 4, plus or minus square root of negative 4 squared minus 4 times 1 times 13 all over 2 times 1. So this is r equals 4 plus or minus the square root of 16 minus 52 all over 2. Okay, 16 minus 52 is negative 36. R equals 4 plus or minus the square root of negative 36 all over 2. R equals 4 plus or minus, that's going to be 6i over 2. So R is equal to 2 plus or minus 3i. So I get complex conjugate roots. Okay, so y1 and y2. Okay, going back to our definition here. For second order Cauchy-Euler differential equation, if I have complex roots, that's going to be x to the a cosine b natural log of x. Okay. So what's a and what's b? Well, a is 2 and b is 3. So this is going to be x to the second power times the cosine of 3. I'm just going to leave cosine outside. Times the cosine of 3 natural log x. And y2 is x squared times the sine of 3 natural log x. Okay, so my general solution would be y of x is equal to c1 x squared cosine 3 natural log of x plus c2 x squared sine of 3 natural log of x. Okay, and, that's my general solution. But now I have to find my constants. It's an initial value problem. Okay, I've got y1 is y of 1 is equal to 2 and y prime of 1 is equal to 5, negative 5. Let's go ahead and take the derivative of this to find out what that y prime is. So that's going to be product rule. Okay, so this is going to be equal to C1, derivative of the first, that's 2C1x times cosine of 3 natural log x plus C1x squared times the derivative cosine is negative sine. There's a minus sine of 3 natural log of x, but derivative of the inside of 3 natural log of x is 3 over x. Okay. Plus the derivative of the second one here. Okay, second term is going to be 2C2x sine of 3 natural log of x plus C2x squared times, oops, C2x squared times the derivative of sine, which is cosine of 3 natural log of x, times the derivative of 3 natural log of x is 3 over x. Okay. Looks good. Okay, so now let's plug in the values that we know. If we let this x be 1, then we get 2. So 2 is equal to C1 times 1 squared times the cosine of 3 times the natural log of 1. Okay, plus, or sorry, yeah, plus C2 times 1 squared. I'll make this equation here. Okay, 1 squared times the sine of 3 times the natural log of 1. Okay. Well, the natural log of 1 is 0. So this becomes 0, and this becomes 0. The sine of 0 is 0. So that would become 0. And that will wipe out everything over there. This cosine of 0 becomes 1. And that's just going to give me C2, or C1 is equal to 2. Okay. Possible. Okay, now let's deal with the y prime at 1. Okay, so y prime is equal to negative 5. So let's put that over here. Negative 5 is equal to 2 times C1 times 1 times the cosine of 3 times the natural log of 1. Okay, minus C1 times 1 squared times the sine of 3 times the natural log of 1 times 3 over 1 plus 2C2 times 1 times the sine of 3 times the natural log of 1 plus C2 times 1 squared times the cosine of 3 times the natural log of 1 times 3 over 1. Okay, so the signs, they go away. Okay, everything's going to go to 0 there. Okay, the cosines survive. Okay, natural log of 1 is 0. The cosine goes to 1. And so I'm left with negative 5 is equal to 2C1. Okay, plus, okay, this thing is going to go to 1. So that's 3C2. That's 3C2. So we know that C2 was 2, so let's just plug that in. 2 times 2 plus 3 C2. C1 was 2. So that's 4. Negative 5 equals 4 plus 3 C2. Subtract 4, we get negative 9 is equal to 3 C2. Oops. Equals 3 C2. Divide by 3. And we get C2 to be equal to negative 3. So that tells me that y of x is equal to, okay, C1, which was 2, times x squared cosine of 3 natural log of x, okay, minus 3, okay, x squared times the sine of 3 natural log of x. And that's my solution. Okay, that's a particular solution. Okay, for those initial conditions. Oops. We have our general solution here. Okay, and we have our particular solution here. Okay, let's do one last example here. Okay. What happens though when we have a non-homogeneous equation? Okay. For a non-homogeneous equation, such as x squared y double prime plus a1xy prime plus a2y equals g of x. In order to find the particular solution, in order to find the using the variation of parameters method, okay, we must first write the equation in standard form. Dividing by the leading coefficient. Leading coefficient. Obtaining a y double prime plus a of x y prime plus, I'll call this a1 of x y prime plus a2 of x y equals f of x. Okay. Okay, number 3. Determine the general solution. Two, x squared y double prime minus 3xy prime plus 4y equals x squared times the natural log of x, where x greater than 0. Okay, so let's look at the associated Cauchy-Euler equation. We have x squared y double prime minus 3xy plus 4y is equal to 0. So this is my, you can think of it as a linear second order differential equation, homogeneous. Okay, is the way we would define a Cauchy-Euler equation. Okay, this is its associated Cauchy-Euler equation. Okay, so let's solve that first. And then we'll try to get the the complementary function, and then we'll try to get the general solution here. Okay. Okay. So we're going to do r squared plus a1 minus 1r plus a2 equal to 0. Okay, so we're going to get r squared minus plus negative 3 minus 1r plus 4 is equal to 0. This is going to be r squared minus 4r plus 4 equals 0. Okay. And so that's r minus 2 squared equals 0. So I have a repeated root. Okay, multiplicity 2. So r is equal to 2. Multiplicity of 2. So let's go back to our table here that says, hey, what happens when I have a repeated real root? Then we have y1 equals x to the r, and y2 equals x to the r times natural log of x. So those are going to be my two functions. Okay, so y1 is equal to x to the r, and y2 is equal to x to the r times the natural log of x. Okay, so my complementary function, yc of x, is equal to c1 x squared plus c2 x squared natural log of x. Okay. Now, how do I find my yp? To find the yp, we need to put this thing in standard form. Okay, if we're working with a Cauchy-Euler equation, okay, we need to put this thing in standard form so we can figure out what a1 of x is and a2 of x is. Okay, so we have x squared y double prime minus 3x y prime plus 4y equals x squared natural log of x. What I want to do is divide by x squared. Let's divide 3 by x squared. Okay, and I'm going to get y double prime minus 3x to the negative first power, y prime, plus 4x to the negative second power is equal to natural log of x. And now it's in standard form. Okay, so a1 of x is equal to negative 3 x to the negative first power, and a2 of x is equal to 4. I'm sorry, 4x to the negative 2 power. Okay, and f of x is equal to natural log of x. Right? Okay, so I want y, okay, I want yp of x, okay, of the form u1 y1 u1 y1 plus u2 y2. Okay. Y1 is x squared, and y2 was x squared natural log of x. Right? Okay, so now let's figure out what u has to be using the variation parameters method. Okay, so u1 was equal to negative integral of y2 f of x over the Wronskian. Okay, and then dx, and u2 is equal to the integral of y1 f of x over the Wronskian dx. Let's just calculate the Wronskian. Okay, the Wronskian okay, it's going to be x squared and then x squared natural log of x. So the derivative here is 2x. And the derivative here is going to be 2x ln x plus x squared over x, which is just x. Okay, so let's find the determinant of this. It's going to be x squared times 2x natural log of x plus x minus 2x times x squared natural log of x. Okay, so this is equal to, distribute, I get 2x cubed natural log of x plus x cubed minus 2x cubed natural log of x. So those cancel, and I'm just left with x cubed. Okay. Now, let's plug this into our integrals. Negative of the integral y2 y2 was that x squared natural log of x times f of x, which was natural log of x, in this case, times or all over x cubed dx. Okay, so the x squared and the x cubed are going to cancel. I'm going to get natural log of x squared over x dx, which is just a simple use of substitution. So u is equal to natural log of x, du is equal to 1 over x dx. Okay, and so this is going to be the integral, negative integral of u squared du. And so this is going to be negative u cubed over 3. Okay, plus c, but again, I don't need to worry about the c because I'm just going to let that go to 0. Okay, and so that's u1. u1 is negative u cubed over 3, but what was u? U was a natural log. So let's plug that in. Negative of natural log of x cubed over 3. Okay, now let's go up and figure out what u2 is. u2 is equal to y1, which is just x squared, f of x, which is that natural log of x, over x cubed, dx. So very similar. Another u sub. It's pretty easy. Okay, this becomes natural log of x over x dx, which is equal to u equaling natural log of x, du equals 1 over x dx. This is the integral of u du, which is u squared over 2 plus c, but let that go to 0. And we're left with u2 equaling the natural log of x squared over 2. Okay, so the particular solution is going to be u1 y1 plus u2 y2, which is going to be equal to negative 1/3 natural log of x cubed times y1, which was my x squared, okay, minus or plus natural log of x squared over 2 times x squared natural log of x. Okay. So this equals negative 1/3 natural log of x cubed times x squared. I'll just put the x squared there. Okay, plus x squared over 2, or 1/2 x squared, times natural log of x cubed. So this is 1/2 minus 1/3, which is just 1/6. So I can combine those two into 1/6. So this just equals x squared over 6 times the natural log of x cubed. And that's my particular portion. So that's yp of x. Okay, yc of x was equal to c1 x squared plus c2 x squared ln x, right? And so putting these two together, we get y of x is equal to c1 x squared plus c2 x squared natural log of x plus x squared over 6 times the natural log of x r cubed. Come on. Whatever. cubed. Okay. And that's the solution. Okay, and that's section 8.8. Okay, and I'll see you in the next chapter, chapter 9.